So here we're going to write a piecewise function to describe this situation. So they get some cell phone plan back in the old days here. This is how they used to operate. There's a base fee of $30. So if you get the plan, you don't use. Let's see, you get for the first 300 text messages for the $30. So we're going to write a piecewise function. We can use f of x. P of t, I guess you use e of t of m or something like that for text messages. And what we're going to do is we're going to write it, use this curly bracket, and it says which includes 300 free text messages. So as long as I send less than 300 text messages, I don't have to pay anything else. So what you do is I'm going to do $30. And the domain of that is going to be 0 to 300. And both of those are closed because I can send the 300 text messages and I can also send 0 text messages. Now after that they charge me 10 cents a message. So I could write it like an mx plus b, and that's what I'm reading. So 0.1x plus that $30, and we're going to use that for 300 to infinity. And of course we have an open bracket at infinity. Okay, so that's that problem. Now they've given us a piecewise function and we have to use it to evaluate it. So what we do is we take a look at f of 2. Well, at 2, when x is less than 0, we're only supposed to use negative numbers for that piece. So this piece says when x is greater than or equal to 0, use this piece of the function. So if f is 2, we're going to use this function here. And so f of 2 is going to just be equal to 2 squared, which is 4. Then it's saying find f of 4. Well, again, looks like that's the same problem. I wonder if this is the typo. We'll have to throw a couple extra in. So again, I'm going to have to use that same function. So 4 squared is 16. And then let's tweak this just a bit. Let's make this be negative 3, just so we can use something a little different. So what's f of negative 3? Well, I'm supposed to use this piece when x is less than 0 or when it's negative. So that's what we're going to do. Negative 3 minus 4 equals negative 7. So that's how it's pretty easy. You just got to make sure you're using the right piece to get your answer. I'm going to tweak this a little bit too, so make sure you do some notes. We're going to write an equation for this, but also what if I wanted to find f of negative 1? Or if I wanted to find f of 3? Well, if I'm looking for f of negative 1, here's negative 1. Here's what y is in the graph. So it's f of negative 1 is actually 1. And so because I had to use that piece of that function. So f of negative 1 is 1. And if I had to find f of 3, well then you're using this piece over here. So that's going to be 2. Now if I had to write an equation for this, I'm seeing a parabola on this end of it here. Whoops. On this end of it here, I'm seeing a parabola, which is x squared. And it looks like it's just plain old x squared. So, let's submit it here. Let's move this up if it'll let me. So, f of x, and I'm going to use a curly bracket. And I'm going to use the function x squared. And that's from negative 2, and it's inclusive of negative 2 because it's closed. It's got that dot. So negative 2, I'm going to use a hard bracket. And then it's open at positive 1, which is a soft bracket. And then we're going to use the horizontal line, y equals 2, when x is 1 or greater. So 1 to infinity. Okay, so that's that easy. You got to think about, the hard part about this is writing, coming up with the domains. Okay, you got to think about when are they closed, when are they open. So the next part of this section talks about the domain. And remember, you talked a little bit about this in Algebra 2. Domain, I can't take the square root of a negative number. That's a problem. I can't divide by 0. That's the other problem. Usually, until we get into logarithms, that's all we got to worry about. So what you do is, this 5 doesn't matter at all as far as the domain. So what I'm worried about is I can't have what's underneath that square root be a negative number. It can be 0. That's not the problem. So basically, I'm solving this inequality. So that I'm just going to subtract 3 from both sides. So x has to be greater than or equal to 3. Using interval notation, we'll call 3 to infinity. Okay? Same deal here. That 5 doesn't matter. The subtraction doesn't matter. It's just going to be negative. The issue is I can't have a negative number. So 10 minus 2x has to be greater than or equal to 0. A couple of ways to do this. I guess I will. Let's subtract 10. So negative 2x is greater than or equal to negative 10. Then I'm going to divide by negative 2. And remember, when you divide an inequality by a negative, you're going to reverse the direction of the inequality. So in this case, it's from negative infinity to positive 5. And that's closed. So it's got to be less than negative 5. We've got a bunch of rational functions. I know they're rational functions because I have a variable in the denominator. Now, I can't divide by 0, right? So ask yourself, when is x equal to 0? Well, when it's 0. So the domain, x can't be equal to 0. That's how you'd write it in interval notation. I mean, yeah, in inequality notation. Set builder notation is another thing that comes up, and you'll have seen that already by now. So I use curly brackets, x such that, the way you say this is x such that x can't be equal to 0. And now if I wanted to use interval notation, it can be everything except 0. So what you do is you say I'm going from negative infinity to 0. It's not closed at 0 because it can't be equal to 0. Or 0 to infinity. Okay. Now this same kind of thing, except we got to ask ourselves, when does x equal 0? When is the denominator equal to 0? Well, when x equals 1, that's the problem. So if we were to use set builder notation, we'd just write x such that x can't be equal to 1. Or if we're going to use interval notation, I'm going to say negative infinity to 1, and they're open on both ends, and 1 to infinity. Okay, this is another one I threw at you just to see, because it involves a little bit of algebra. So when is that equal to 0? Well, when x equals to positive 4/3 is the issue. So again, negative infinity to 4/3, those are open, and then I'm going to run out of room. 4/3 to infinity. Okay. Now I threw these two on there because these are a little bit different. It's still, we're looking for the domain. We're still worried about the denominator. We don't care about that numerator. That numerator has got a variable in it, but we really don't care because if x equals, if x equals 1/3, what does that do? 3 times 1/3 minus 1 over 2 times 1/3 plus 1. Well, that's going to be, let's see, 3 times 1/3 is 1. 1 minus 1 is 0. And on the denominator, that's going to be 2/3 plus 1 is going to be 1 and 2/3, right? Or we could say that is what, 5/3? Well, what's 0 divided by anything? 0. So that's not a problem. The issue is the denominator. So what you got to worry about is that when is that equal to 0? So when 2x equals negative 1, or when x equals negative 1/2, we get it 0 in the denominator. So we're going to say negative infinity to negative 1/2, open on both ends, negative 1/2 to infinity. Okay, now for this last one, again, the denominator is what we got to worry about. So x squared minus 4x plus 3, where is that equal to 0? This is the reason I've been having you do some math minutes. How does that factor? It's a quadratic equation. I got to decide how that solves. So let's see, I get x and x, and what multiplies to give me positive 3, it will add to give me negative 4, well, negative 1 and negative 3. So that tells me the zeros of this are positive 1 and positive 3. So to write interval notation on this, I would go from negative infinity to 1. I would skip over 1, go 1 to 3, skip over 3, then 3 to infinity. Anything else works. I mean, those are anything in this range works. 1 and 3 do not work, so I gotta inform people about that. So that's the domain of that function. Jump in and do some of that book work now.